The first human beings that will be able to live to 2,000 years old have already been born. Says professor at Cambridge who works at several companies and institutes in Silicon Valley. He's an expert in biomedicine and aging. Ladies and gentlemen, our next speaker is Aubrey de Grey. Aubrey, thank you very much for joining us.
My pleasure.
I'm 29. What's my chance to live to 1,000 years?
You're 29?
Yeah, I'm 29.
I don't believe you.
I'm not really certain. Should I take it as a compliment or?
You got a pretty good chance.
Okay, thank you. What's the answer to my question? Will I be able to live to 1,000 years?
You've got a pretty good chance.
Yeah, really. What's the chance? Could you say, a percentage?
Well, of course. So, I mean, let me answer the question in slightly more detail.
Okay.
The answer I have when people ask me how long I expect to live is that the least likely range of ages at death is 3 digits. Okay. It's more likely that I will live 2 digits or 4 digits, and less likely than 3 digits. Because it all depends whether I make the cut, whether I live long enough for the therapies that we're developing and that other people are developing to rejuvenate me so that I can be serially rejuvenated.
Okay, please take us in.
Take it from there. Good evening, everybody. So I love speaking to Singularity audiences. I've spoken at the graduate summer program at Singularity University in Mountain View every year since Singularity University was founded. Peter Diamandis and I have been good friends for nearly 20 years now. So, I'm very much part of this community. But this is the first time that I have had the honor to speak as the last speaker of the day. And it's a real honor because I have the benefit of all of the inspiration that has been given to the audience for the whole rest of the day. I actually missed the first session. I only arrived here from Vietnam around 11 a.m., but I've been here watching pretty much every talk since that point, and it's been wonderful. So what I'm going to do today, actually, since this is the kind of material that you guys are familiar with, I guess that I don't have to give too much background. What I'm going to do is I'm going to run through my slides a bit more quickly than I normally would, so that I can give a bit of time, maybe 10 minutes, just to riff, really, just to extemporize and talk about how wonderful it is to be living as exponential thinkers in this time in the history of humanity. But yes, first of all, I guess I'd better kind of tell you what I do, for those of you who don't know, and why it's important and all that. Aging is quite bad for you, really, and we've kind of known it for a long time. We just had a wonderful humorous comment a moment ago about hacking, about how everyone knows it, but nobody wants to talk about it. That's exactly the situation that humanity is in with aging. Aging is completely obviously the world's most important problem. More than 2/3 of people die from aging, from causes that young people don't die of. And furthermore, they die in general after a long period of decline and disease and decrepitude and general misery. It's completely obvious. But people don't want to think about that. They just want to think, well, maybe it's some kind of blessing in disguise. Or, well, it's just how things are. There's nothing we're ever going to be able to do about it. So let's just make our peace with it. And of course, the reason they think that way is just psychological. People think that way because they don't want to get their hopes up. They are scared of being disappointed. I think that if there's anything that really defines what it is to be an exponential thinker, it is not to be scared to be disappointed. We know that exponential change is only roughly exponential. You know, Ray Kurzweil, when he talks about this and when he writes about this, he explains how if you look closely at exponential change, you see this series of S-curves, you know, this kind of oscillation between rapid change and, you know, things slowing down and then the new innovation comes along. And, you know, that's fine. But, of course, it does mean that if you try to get down to the details of the timing, you're going to be a little bit wrong sometimes. And we need not to be scared about that. And I believe that the kind of person who gets involved with the Singularity University, with SU, and with the whole community is the kind of person who isn't scared of that, who understands that having the courage to try, to aim high, is far more important and far more fulfilling than not having the courage to be disappointed. So I'm going to really give a talk along those lines. This is, of course, what we try to do. We try to develop technologies that will bring aging under complete medical control. In other words, you won't be able to tell the difference between someone who is 20 and someone who is 120 from just looking at them or seeing how well they dance. You will not be able to tell. And the reason you won't be able to tell is because the function of those two people will be identical, and that will be because the structure of those two people will be identical. There will be no more, if you like, damage in the bodies of the older people than in the bodies of the younger people. And we will achieve that in exactly the same way that we already achieve it in simple man-made machines like cars, namely by periodic, comprehensive damage repair, preventative maintenance. That is something that humanity has somehow had trouble getting to terms with. We've got a real problem right now, a really paradoxical problem, that we've made virtually no progress against the ill health of old age, despite the fact that over the past 150, 200 years, we have more or less eliminated most infectious diseases in the whole of the industrialized world. And we did it by really simple measures, like discovering that hygiene was a good idea. Now, aging is just the accumulation of self-inflicted damage. If we put it in, biological terminology, then metabolism creates damage throughout life, even starting before we're born, and that damage eventually causes the ill health of old age, the pathologies of old age. Now, of course, the pathologies of old age are, well, there are lots of them. Don't worry, you're not supposed to be able to read this slide. There's just a lot of bad things happen. And most people think that that's why we have been unsuccessful in developing medicine that stops us from getting old, from getting sick when we're old. But actually, that's not the main reason. The main reason is that we think wrongly about aging. Most people think that aging is this very weird thing that is completely separate from the various types of disease that people can have. The infectious diseases that you see here in column 1, and the inherited genetic diseases in column 2, and then, of course, the chronic progressive diseases of old age in column 3. That's what most people think, and that's what has led to the spending of huge amounts of money and time and effort on geriatric medicine, which can be summarized as pretending that column 3 is like column 1, that the chronic progressive diseases of old age are like infections. Because ultimately what geriatric medicine tries to do is it tries to eliminate the pathologies of old age from the body, literally get rid of them, in the same way that one might get rid of an infection. And that's obviously impossible because these pathologies are a side effect of being alive. If we think about it rationally, and we just demystify the whole business of aging, we can see that the definition of aging that I just gave, this 3-word definition, essentially coming down to aging being the accumulation of self-inflicted damage, it's the same definition that we would use if we were defining the aging of a car. Aging is not some kind of emergent phenomenon like consciousness that only exists in machines that are really, really complicated, like living organisms. Aging is just the same in a simple machine as it is in a complicated one. And of course, the reason why we only suffer ill health late in life is the same reason why a car only suffers ill health late in life. Namely, that all machines are set up to tolerate a certain amount of damage before they go downhill. So the real way to think about the taxonomy of disease, the taxonomy of sickness, is like this. In this version of the table I showed you earlier, all the columns are the same as they were before, but the big black line is in a very different place. And that's critical. What it emphasizes is that column 3 is nothing like column 1, and it's very like column 4. Column 3, the chronic progressive diseases of old age, which are the target of most of our medical expenditure today, they are being misclassified, and as a result, we are misdirecting most of our effort to try to do anything about them. In fact, really, those things are just parts of aging. And the only difference between column 3 and column 4 is that column 3 is the aspects of aging that we have chosen to give disease-like names to. Now, one way to respond to that realization is to say, well, okay, let's clean up metabolism. Let's somehow slow down the rate at which the body generates this damage in the first place. And that's really what the whole field of the biology of aging does. It's the idea of trying to understand aging really well, in particular to understand the variation that exists in the natural world between the rates of aging in different species, or even the rates of aging of different individuals within a species. That sounded like a great idea for a while, until we realized this, that metabolism is so complicated that there's just no way that we're ever going to be able to tweak it so as to stop it from doing the thing we don't want it to do, the creation of damage, without at the same time stopping it from doing things we need it to do. It's just not going to happen. But luckily there's this third approach that we can adopt, which was inexplicably just overlooked until I came along and talked about it about 15 or 17 years ago. The maintenance approach is simply damage repair. If we eliminate damage periodically, even if we don't do it particularly perfectly, even if we only eliminate a certain amount of damage every so often, then we can leave metabolism alone. In other words, we can let metabolism generate damage at the normal rate, which means that it's okay that we don't understand much about how metabolism really works. So that's, quite useful. And of course, it already happens. We already successfully do this with cars and airplanes and other simple man-made machines. This car is obviously a vintage car. It's more than 100 years old. The reason I'm showing you this car is not just because it's nice and old. The reason I'm pointing out the importance of this car is that it was not designed to last 100 years. It was only designed to last maybe 10 or 15 years. And then, the people who built it would never have believed that any of the cars they were building would live this long. The reason it has lived this long is because it has been owned by people who just decided to do an unusually comprehensive job of maintaining it. They just did better than normal at removing the damage that the car was doing to itself by driving. And here it is. Maintenance works. Now, of course, the body is much more complicated. Everything I'm saying on this slide I've said before, except for the bottom line. The bottom line is important. The damage in a car is simple, because the car is simple. The damage in the human body is more complicated. But the fantastic good news is that even though the damage in the body, in the human body, is more complicated than the damage in a car, it's much, much less complicated than either metabolism or pathology. In particular, I mean, I've shown you how complex pathology is with that huge list of problems that people get. I've shown you how complicated metabolism is with that huge chart. This is damage. It's not too bad. There are only 7 different types of damage that we need to worry about. Those are the things on the left-hand side of this table. The things on the right are the ways to fix them. And the first piece of good news here, of course, is that there is an entry for every row on the right. In other words, for every type of damage that we know about, every aspect of the changes that the body accumulates over time that eventually are bad for us. For every single one of those 7 types of damage, we have a way of fixing it. Now, there's another piece of good news on this table, which is the bottom line, the line at the bottom there. You may think, well, how does Aubrey know that there isn't some category number 8 out there that we just haven't discovered yet? And I can make various biological arguments for that. The best argument, though, I think, is the circumstantial one. We have known about all the other 7 for more than 35 years. That's a very long time not to find anything out. So it's looking good. But yes, the main thing is that on the right-hand side there's an entry. Now, unfortunately, we haven't actually developed all of these things yet. We're getting really a long way along with the first one, stem cells, which are, of course, the way to repair the damage at the top, the damage of cell loss. Cell loss is simply cells dying and not being automatically replaced by the division of other cells. And stem cell therapy is simply doing that replacement, putting cells into the body that have been pre-programmed into a state where they will divide and transform themselves into replacements for the cells that the body is not replacing on its own. That's all that stem cell therapy is. So that's fine. You know, stem cell therapy is going fine. There's lots of people working on it, lots of money behind it. We at SENS Research Foundation don't do any stem cell research, and that's why. We don't need to. All of the other categories, unfortunately, are much less far along. There are some areas that have been in clinical trials already, but mostly these are things that were at a very, very early stage of research when we got involved. And I'm very proud to say that we have changed that. This is just a summary of some of our publications over the past few years. These are publications arising from work that took us several years to achieve. If we look at the bottom one, for example, that's the first paper from a project that began in 2005. And the only way that we were able to do that was by setting ourselves up as an independent non-profit, which did not depend on community support and peer review and stuff like that. We were able to pursue things just as long as it took. And it did take a long time. But these things are now moving forward really well. We are now being recognized by the wider community as being the real leaders in some of these areas. And that's purely because of the breakthroughs that we made that had not been made for maybe 15 years or more by anyone else in the community, because they were just handicapped by the restrictions of their own funding options. An example that I like to talk about is this one with regard to atherosclerosis, the number 1 killer in the Western world. This is the beginning of atherosclerosis, a foam cell, which is a cell that used to be a very healthy white blood cell, and it was poisoned by oxidized cholesterol. We were able to identify an enzyme in bacteria that can break down oxidized cholesterol. And after a lot of tinkering, we were able to get this enzyme to work in a human cell. And the result was that cells were protected from this toxic molecule. There's still a way to go to get this into the clinic, but we believe that when it is in the clinic, it's going to be a far more effective treatment against atherosclerosis than anything that exists today. And of course, atherosclerosis is the #1 killer in the Western world, so that's quite a big deal, really. Similarly, as I mentioned, we have gained increasing recognition of the legitimacy and indeed the promise of this approach. What I'm showing you here is simply our research advisory board. These are world-leading scientists across the whole spectrum of areas that we work in, and it's very nice to have people like this giving explicit, very unequivocal endorsement of this damage repair approach. What's perhaps even better is this. So this is a paper which essentially reinvents what I started saying more than a decade earlier. And as you can see, it came out 5 years ago. Now, in those 5 years, this paper has been cited in other papers more than 1,000 times. So it's around 1 citation per day. That is not very common. In fact, I think it's almost certain at this point that this paper will become the most highly cited paper in the biology of aging of this decade. And that's what matters to me. I'd quite like to have actually got the credit for having invented this idea, but I don't really give a damn about that. What I actually care about is that this is now mainstream. It had to be reinvented by people with more letters after their name and so on, but so the hell what? The fact is, people now get it. They divided aging into 9 categories instead of 7, but it's exactly the same idea, and they had their corresponding therapies. So this is wonderful. This is now an orthodox concept. But now, let us come to the wider context of all of this, and let us link it in with all of the other issues that we in this kind of audience think about and that we've been hearing about today, and there'll be more tomorrow. We like the idea of living forever. We like the idea that, if life is good, then more life is more good. We understand that. But a lot of people don't. People who don't think exponentially, often they don't think linearly either. They think more kind of logarithmically or asymptotically. And that's very scary because it really, really slows down progress, and it really, really causes a lot more suffering to happen than it could be. But what it means for people like me is that I have to constantly tell people that longevity is not the point. And to me, I'm not lying, because the fact is, longevity isn't really the point for me. For me, the point is, I just don't want to get Alzheimer's disease when I get older. And I don't want any of you to get Alzheimer's disease either, and I'm fairly sure you don't want each other to get Alzheimer's. It's not exactly very controversial. So all I really have to get across to people is that we work on health. We just do medical. This is just medicine. And that any longevity consequences are just consequences. They're just a side effect of staying healthy. Because let's face it, most people die of being sick rather than being hit by a truck or whatever. So, on average, most people are going to live longer if we don't let them get sick. And that's so important to emphasize. Whenever any of you are talking to your colleagues, your friends, your family about this kind of thing, you will find them saying negative stuff. Saying, well, aging is some kind of blessing in disguise because it would be terrible if we lived longer. You want to start by saying, no, dummy, this is about keeping you healthy. And, I think this is really important. On the left-hand side here, I have listed a selection of the questions that I have answered perhaps 30,000 times in the past 20 years that I've been doing this job. And it's very boring answering these questions, but it's also very frustrating that I give my answers and I don't get any pushback. I don't get anyone saying, here is the problem with your answer. I just get this kind of wet flannel, kind of like changing the subject or whatever. But I know that what's going to happen is I'm going to get the same fucking question the following day. Nothing changes. It's very, very frustrating. Now, we've seen today, in Mez's talk, for example, the answers that we would like to give, the real answers to the questions on the left. The fact that overpopulation is only an issue because of pollution. We could perfectly well have far more people on the planet if we had more renewable energy. Or, of course, Mark Post's talk, if we had more artificial meat, less pollution. If we had better desalination, all of these things. It's completely obvious. And, the question of how will we pay the pensions? That's the kind of thing that comes up. Tomorrow, I gather we're going to have a bunch of talks about artificial intelligence. I used to work in artificial intelligence before I was a biologist. And the main reason I did was exactly that I thought that it was really bad that people had to spend most of their lives doing things that they wouldn't do unless they were being paid for it. It is bad, right? And at the end of the day, artificial intelligence for me is all about automation. It's all about allowing people not to work. And if we actually succeed in doing that, then yes, we've got to invent all these new structures like universal basic income and so on. But, worrying about the pensions, for Christ's sake. Everyone's going to be more prosperous because machines are going to be doing stuff. Hello. It's so bleeding obvious. I love the immortal dictators one. Last I heard, dictator was fairly high on the league table of risky jobs. If you're a dictator, you tend not to die of aging in the first place, really. And furthermore, if you do die of aging, then you've had time to set up your succession, so it's as if you were immortal anyway. So, come on. But it just doesn't work. Okay, so I actually have tended to gravitate to the things on the right. The reason I've put those little braces there is because the three arguments on the right are equally powerful refutations of any of the things on the left. They're generic refutations. The health one is kind of what I just said. Hello, boys and girls, this is not about longevity. This is about actually keeping people in a good state of health, and people like that. Eventually I end up putting people on the spot and I say, look here, tell me the difference between A, saying aging is a good thing, and B, saying medicine for the elderly is a bad thing. There's no difference. If you're saying that aging is some kind of good thing and that it would be bad if we fixed it, then what you're saying is that medicine for the elderly is only a good thing so long as it doesn't really work. That's what you're saying, right? And I have never had anyone actually admit to the fact that that's what they're saying. But it sure as hell shuts them up, briefly. So that's a good start. Then sense of proportion. Look, I cannot utterly guarantee that Elon Musk and his friends will actually solve all the problems on the left. And that we will actually get all of the technological advances necessary to avoid all of these potential difficulties that might be created as a side effect of solving the problem we have today. I cannot guarantee it. I don't care that I can't guarantee it, but some people do care. But even if we can't, have a sense of proportion. How many people die each day from aging? You want to know? It's more than 100,000. That's 30 World Trade Centers every single day. And I mentioned, of course, all of the decline and decrepitude and suffering, right? How bad can a problem be to be so bad that it's worth keeping the problem we have today? How bad would it be to have fewer children than we would like? Not many people actually are willing to say that if they were given the choice between having fewer kids or having Alzheimer's, they'd take the Alzheimer's, right? And to me, the most fundamental, the most unequivocal moral argument is the one about choice. If we were to say, overpopulation, terrible thing, let's not go there, then what we're doing is we are slowing down progress. Eventually, we're going to defeat aging with medicine. There's no question. It's as Ramez said earlier on, it's not a question of if, it's a question of when. But the question of when is rather important. Every day that we delay is 100,000 people that we're condemning to death. And we don't have the right to do that. People in the future who might or might not be able to benefit from therapies that defeat aging, depending on whether we get on with it now, those people will know more than we know now about the circumstances, about what other technologies have been invented, things like that. And they will be in a better position to choose whether to use these technologies. So we have an absolutely unequivocal moral obligation to develop these therapies as soon as possible and to get the hell on with saving lives, even if we don't think they might. I mean, of course, there's a range of opinions about how soon these therapies are going to come along. I know perfectly well that this is pioneering technology, and it could be 20 years or it could be 100 years. But I don't give a damn which of those it is. All I care about is that I'm putting my life into bringing it forward. I don't care which 30 million lives I save, just so long as I save those lives. So now what I'm going to do is give you some really good news. I know I've got a bit angry over the past 5 or 10 minutes, but now I'm going to get a bit happy. Because I've been doing this a long time. And I know quite a few of you in the audience have been on the same message for quite a long time. And it really is finally beginning to stick. The fundamental thing that's happening is that there is a sea change both at the bench, in the laboratories, and in the wider world, in terms of the attitudes to all of this, to both the feasibility of defeating aging with medicine and the desirability. On the feasibility side, well, I already gave you a taste of this with some of the publications that we've put out over the past few years. These publications have real meaning not only to other academics, but also to wealthy people. And that's rather important because, in my experience, most wealthy people don't like giving money away. They kind of just don't like it. I've got a lot of people I know who are really supportive verbally of this mission, but they've never given the foundation a penny, and they'll blame their wives for being against it or whatever. I don't know whether that's true, but the fact is they don't give us money, and that's not good. But luckily, when you get a project far enough along, it becomes investable. And here's the really good news. You only need a few investors, just so long as they've got a bit of cash. We heard, well, of course, we know all about how exponential technology is driven by information. I love the comments earlier about how a cell phone isn't really a piece of hardware, it's a piece of non-material information. I think that's absolutely correct, and it underlies the whole concept of exponential change. But it's not just magic. That accumulation of ideas happens because of pioneering technologists and scientists who have the ideas. And it's not just the technologists who need to be pioneering and visionary. It's also the people who give them the financial resources to get the hell on with it. So the extremely gratifying fact is that we at SENS Research Foundation are finding that we have an audience of investors who are visionary enough to get involved. They may be very unwilling to give us money, at least initially, but if we get a project to a point where we can spin it out into a startup company, the whole thing changes. Here's one example. This is a company that was spun out from the project that we worked on for several years on macular degeneration, the #1 cause of blindness in the elderly. And it's so far received $6 or $7 million in seed money. It's going to have a Series A very soon. It's probably going to be in clinical trials within a year. We could not have got it that far, but it managed it because it went private. Here's another one. Covalent Bioscience comes from a project that we funded for several years in the University of Texas in Houston. It's looking at amyloidosis, which is in the heart, which is the number one killer of centenarians. Here's a company that's run by someone who used to be our chief operating officer. It's working on a cryopreservation solution to the organ transplantation shortage. And again, this is a company that's recently been funded with seed money to keep it going for getting more useful data. Here's a company looking at a genetic approach to the elimination of senescent cells, which is something that you may have heard about because of a very high-profile company named Unity Biotechnology that has been pursuing the elimination of senescent cells using small molecules. I want to mention Unity a little longer because Danielle Strachman this morning talked about Laura Deming, one of the first crop of Teal Fellows that she oversaw. And Danielle mentioned that Laura changed tack during the fellowship and went from wanting to do research to wanting to run a fund. I think Danielle mentioned the numbers involved, and they didn't sound very impressive, really. Laura brought in $4 million, really tiny fund, about 4 years ago. And then 3 years later, well, 3.5 years later, just in the past few months, she's raised a second fund of $22 million. Now, that doesn't sound very exponential. But what Danielle didn't mention was that the original $4 million was invested rather well. Those dollars went to only 5 companies. Every one of those companies did extremely well, and one of them was Unity Biotechnology, which, on the back of what they couldn't have done without her money, they raised a 9-digit Series A last year, $120 million. So her original $4 million fund got an IRR of 188%, which, is, for those of you who know what an IRR is, and I'm not quite sure, that's quite exceptional. Which means that if she had wanted to, she could have perfectly well raised $500 million for her current fund. But she didn't want to do that. What she had the smarts to do was to stick with a winning formula. The fact that she has, first of all, an absolutely exceptional scientific brain. She really knows how to do scientific due diligence. And secondly, as we have now seen, and I must say it's a very unusual combination, a very good funding brain, an investment brain. So she wants to carry on being essentially a one-woman band and to stick to what she knows. So she chose to keep her fund small. But I assure you that Laura Deming is an influencer on the scale of me in this field, really. Everybody comes to her, just as everybody comes to me, for advice about what to do. So this is a massive success story of the Teal Fellowship. And I actually also want to mention the other person that Danielle highlighted today, Vitalik Buterin, who, of course, is well known to all of you here as the founder of Ethereum, and who created Ethereum while he was a Teal Fellow. Now, the reason I want to mention Vitalik is because he read my book when he was like 13. And he's been a big fan of my work and the Defeat of Aging all his life. And he's done well, and lo and behold, he's decided to give back. He gave us $2.5 million of Ethereum in December. That is quite nice. It makes our lives very easy. I mean, very much easier than they were. The budget of SENS Research Foundation is only $4 million per year. And he wasn't the only one, actually. 3 other people who did very well out of the explosion of cryptocurrencies a few months ago also gave some of that money to us. So we had a real windfall. The reason I mention all that is because the spinning out of these projects into startup companies is not something that just happens all at once. Each project has its own timeline, determined by, first of all, of course, the money that we have available to put into it, but secondly, the sheer difficulty of the science. So there is plenty of work that still needs to be done that is not yet investable, even by real visionaries. And that's why the foundation still exists. That's why we have this initiative, we call it Project 21, to bring in more money. Project 21 is really all about getting to clinical trials fast. And we called it that because we reckoned when we set this up in 2016 that 2021 was a good estimate for when we would be able to get most of the SENS projects, SENS interventions, into the clinic. We still think that's true. And luckily, this is a concept that is resonating. We have people like Vitalik who have just chosen the philanthropic route and who, as far as I know, have not yet chosen to invest in any of these startups. We also have plenty of people who have come to us and who have, on our recommendation, invested in these startups and in other affiliated and associated startup companies. But the fantastic news is that they recognize the logic that the non-profit sector, the foundation, is the essential engine room of the industry. So those people are donating to us as well as investing in the companies. And I am absolutely delighted that that is happening. I really want to end by saying that the whole way of thinking that is heralded and highlighted by the Singularity University movement and was so ably articulated by Peter Diamandis this morning, despite the fact that he was speaking at 6 a.m. his time. This is something that is never, I believe, going to come naturally to people. We've heard, I think Peter actually himself mentioned, how we just were not evolved to think that way. We're evolved to think short term, we're evolved to have fear of the unknown and all of that. It's up to the minority to lead the way here. I mean, of course, the minority also always leads the way. The goal of a scientist or a technologist is to be in a minority of one as often as possible and as briefly as possible until they persuade other people that they're right. But the fact is, not many people can do this. And you people in this room, you're like me. You are leaders. You wouldn't be in this room otherwise. You are the kinds of people who have the opportunity to go out there and make a huge difference to humanity. Not necessarily in the biology of aging, it could be in any of the technologies that we're hearing about at this meeting. And by having that opportunity, I hate to say it, but the fact is you also have the responsibility. You cannot walk away from this. If you're interested in this, and if you're talented, tough. You've got to do this, same as me. Thank you.
I would like to start with a question from the area that you hate. Zach Tiger is asking, if people live for 1,000 and more years, won't they lose their drive and their initiative that creates the innovation we are talking about right now?
Yeah,
Doesn't the fear of death make life more variable?
Yeah, bullshit. Okay, my standard answer to this is fairly amusing, so I'll give it. So, if you're thinking that way, if you're thinking, oh, wouldn't we lose our sense of urgency, then what I want you to do is this. I want you to take yourself back to the first time you had sex, all right? And I want you to ask yourself, what were you thinking immediately beforehand? In particular, were you thinking, oh my God, I have to get this person into bed right now because I've only got another 60 years to live? Probably not, right? You were probably thinking in more short-termist ways. And this is normal. There is virtually nothing that we do in life that is actually based on how long we expect to live, except for stuff like health insurance and, pension plans and so on, which have nothing to do with urgency, right? Stuff that actually drives us to excel and to work hard is basically self-esteem. Peer pressure, stuff like that. And that has nothing to do with how long we expect to live.
Are you living a happy life?
Pardon?
Are you living a happy life?
Fuck yeah. I mean, I've had the most... I mean, come on. I have the most unbelievable life. I have lived my whole life since I was a young kid with the ambition to make a real difference to the world, as much difference as I can. And I've ended up in this unbelievable position of spearheading the global crusade against the world's biggest problem. So I'm probably making more of a difference to the world than anyone else on the entire fucking planet. How could I possibly not be happy?
Well, if you are living on a fucking planet, I think it's a quite nice planet.
Yeah, I mean, this is what I wanted to do with my life, and I'm doing it. So, how could I not be happy?
Have there been any obstructions attempted to be created on the path of your research by the government, medical conglomerates that benefit from the sick people? If so, how have you dealt with them?
Yeah, no, there really haven't. And this is kind of the flip side of the difficulty that we have in persuading people to support this mission. The people who won't support it, ultimately, the way they justify not supporting it is by saying it's all science fiction to themselves. And if they're saying that, then they're not going to get worried about it. So they're not going to try and slow me down. They might not try to speed me up, but at least they're not trying to slow me down.
This is a question sent by Martin Yasso, and please be very honest, okay, in your answer.
Does it sound as though I'm not being honest in the other...
I'm stressing out the word very honest, okay? Did you ever wonder how long your beard would be if you lived 1,000 years?
Well, actually, no. I'm afraid I have a very boring answer to that, which is that I started growing this beard in 1995 at the behest of my ex-wife, and it grew from nothing to this long in just 2 years.
And then nothing?
Yeah, that's right. Nothing happened after that. I don't trim it or anything. So by the time I started really thinking hard about this kind of stuff, and certainly by the time I invented SENS, which was the year 2000, I already knew that the beard wasn't growing anymore, so I didn't have to worry.
Maybe you need some stem cells, to help out.
Maybe. Then again, maybe not.
Maybe not. It will be definitely up to you. Ladies and gentlemen, Aubrey de Grey. Thank you very much indeed.